Okay, so let's get started. Where would be our first, what would be the first thing we would do here? Okay, how would we cut it?
90 degrees.
So we're going to cut it 90 degrees here, and then 90 degrees here. So now we need to know X and Y here to find the area of those rectangles. But to find those, we would really need to find these dimensions, A and B up here. So what we really need to focus on is this weird little shape thing here. What do we know about it? Well, we know we've got 90 degrees, 90 degrees, and 130 degrees, which makes this one have to be 50 degrees. Now what? Yep, they have to equal 360 because it's four-sided. Yep. How do we cut this thing? 90 to 90. So we're going to cut it across here. Now, what else do we know about it right now? That's 36, and this is 28. So that means we can find this piece right here, if I call that C, using law of cosines. C squared, or C, is equal to the square root of 36 squared plus 28 squared minus 2 times 36 times 28 times the cosine of 50. Minus 2 times the, remember it's 2 times A times B times cosine of C. So second square root, 36 squared plus 28 squared minus 2 times 36 times 28 times the cosine of 50. 28.002. So this is actually 28 feet here. That worked out really conveniently. 0025. Well, we're going to stick with 28. Now what? What's that? Law of sines is going to tell us that this angle here, if I have 28 over the sine of 50 degrees equals 28 over the sine of that angle, guess what? This is 50 degrees. We have to do an inverse sine, right? 80. Because they have to add up to 180. Right? Sine of theta. Yep. So you're going to cross multiply and divide here. And you're going to get the sine of theta is 0.766. You're going to do an inverse sine of that. And get to this 50 degrees. So that's where the 50 comes from there. Then we subtract from 180 to get the 80 degrees here. So that means this angle here is 40 degrees because that's a 90 degree angle. And this one here is 10 degrees. Do those add up to 180 there? Yes, they do. So now that we have all three angles and we have one side, we have the 28. That's going to be 28 over the sine of 130 equals A over the sine of 10 degrees. So sine 130. Oops, wrong way. Let's do the sine of 10 times 28 divided by the sine of 130. Gives 6.35 for A. So this is 6.35 here. So 6.35 feet here. B then is going to be C over the sine of 40 again. So 28 over 40, or 28 over sine of 130, I should say, equals B over the sine of 40. So sine of 40 times 28 divided by sine of 130. This angle here. Nope, it's 40. So 23.49 we get there. So what that means is that this here, y is 12.51 feet, 36 minus the 23.49, and this over here is 45.65 feet, 52 minus the 6.35. From there, the areas should just kind of fall into place. We've got area 1 here, which will be 45.65 times 36 is 1643.4. Area 2 over here, which is 12.51 times 28, $350.28. Then we'll call this one here area 3, 6.35 times 36 over 2. Giving us 114.3. And area 4 here, which is 23.49 times 28 over 2. Gives us 328.86. So if we add those all up, $2,436.84 square feet. Anybody have that on their own? Anybody heading in that direction just ran out of time? Anybody have absolutely no hope of ever solving a problem like that on their own? So what you're saying is the quiz I'm about to give you might be a bad idea? Let's take a look at your worksheets you had from yesterday. Or from Friday, whatever. The last time we had class. When last we met. How's that? So we're going to look at worksheet 4-23A. The first front side there, number 1. X is 15.21 feet. So phi, which is this one, is 41 degrees. Theta is that one is 87 degrees, which makes the area 59.92 square feet. How many of you had that one all right? Anybody have questions on it? Okay, number 2. X is 6.1 feet. Phi, which is this one, is 123.2 degrees. You got to remember to do the supplement because it's obtuse. Theta is 14.8 degrees, and the area is 40.8 square feet. Anybody have that one all right? Mostly. Any questions on that one? Number 3. X is 11.28 feet. Y is 12.5 degrees. Or, sorry, 12.5 feet. I don't know where I got degrees. 12.5 feet. Theta is 58 degrees. And the area, what's that? You got 55? 59 for the degrees? Subtracted wrong. You just got to take 180 minus 72 and 50. You try to do law of sines. Just round off error is all it is. Area, you'll notice it asked for the area in acres. I mean, you could have done A times B times sine C over 2 to get square feet. Or which angle did you use to find area? Did anybody pick one? Let's do the 50-degree angle. So I'll do 14 times y is 12.5 feet times sine of 50 degrees, excuse me, over 2. Gives us an area of 67.03 square feet, but it asks for it in acres. How do I convert that into acres? Divide by 43,560. Gives us 0.0015 acres. How many of you had that one all right? Mostly. Any questions on that one? Number 4. For number 4, x is 18.2 feet. Phi is 97.8 degrees. Theta is 34.2 degrees. And the area, same process, will give you 0.005 acres. No? Any questions on that one? Number 5, theta is 76.5 degrees. The area is 2,510 square feet, give or take a square foot. So then 0.058 acres, 0.0576 acres. No? Any questions there? Anybody have that one all right? What'd you miss?
I had trouble getting started.
Okay. Number 5 actually is a little tricky. You've got 86 degrees here, 45 feet, 51 feet, 54 feet, and 52 feet here. And you're looking for this angle up here. You're going to have to cut it this way. Pretend that's a straight line. Then we'll figure out the length of that line using, if I call that C, C is equal to the square root of 45 squared plus 51 squared minus 2 times 45 times 51 times the cosine of 86 degrees. Second square root, 45 squared plus 51 squared minus 2 times 45 times 51 times cosine 86. So it's 65.62 feet. Once we have that, now we need to use that to find theta. So that's still C. So 65.62 squared equals 54 squared plus 52 squared minus 2 times 54 times 52 times the cosine of theta. Now remember, we're going to treat this like it's our variable. So I'm going to square this again. You get 4,305.82. Then we're going to do 54 squared, 2916. 52 squared, 2704. And then we're going to do 2 times 54 times 52. It's going to give us 5616. And that's times the cosine of theta. Again, we're still treating this like our variable. I can combine those two because they're just added, which adds up to 5620. And now I have to subtract the 5620. Which is going to give me 1314.18 negative, I believe, equals negative 5616 equals cosine of theta. And now I'm going to divide by a negative 5616. So cosine of theta is going to equal whatever I get dividing that. Now a negative divided by a negative is a positive. So 1314.18 divided by 5616. I left the negatives off because I know it's going to be positive. So 0.23400. So theta is the inverse cosine of that. So second cosine, second answer. 76.46 degrees, 76.5 degrees is what I rounded it to. Now once you have that angle, it's just a times b times sinus c over 2 to get this area. A times b times sinus c over 2 to get this area. Add them together. Make sense? Did I lose you?
I got the hypotenuse as far as
Okay.
now you
Yeah,
working backwards to get the
yeah, I'm using the law of cosines here where I'm missing the angle instead of missing the side. Normally we're missing this side and we're just putting everything in to calculate it. Here I was missing the angle, so I had to write out the whole formula and solve it like an equation. Yep. So basically what I'm doing is I'm treating this like it's the variable and I'm combining everything that I can here. I can combine all this to get the 5620. I can combine all this to get the 5616. Then I've got this equation here, so I've got to subtract the 5620, then divide by the negative 5616. That's how I got cosine of theta equals that. I did the inverse cosine to solve for theta. We did a couple of examples like that a couple of weeks ago when we did our law of cosines, but it's an obscure application of the law of cosines. It doesn't get used a lot, but it's very, very handy when you need it. Another way you can look at it, you may want to write this down. You could look at it as the angle is equal to the inverse cosine of c squared minus a squared minus b squared all over 2 times a times b. Or that should be all over negative 2 times a times b. Everybody have that down if they need it? Not yet. I'll give you a second. Okay, ready? Okay, number 6 then is pretty much the same type. I just didn't ask you for the angle. So for number 6, since I didn't ask you for this angle up here, we don't need to use that. So all we have to do is we find this. We can use a times b times sinus c over 2 to get this area. Then we use Hero's formula to get this area once we know, because we know all 3 sides. So for number 6, the area was 158,403.96. So 158,404 square feet. Anybody have that? So it comes up to 3.64 acres. Number 7. Yeah.
How did you use Hero's formula?
Okay, so what I did, you were given 389, and I'm going to convert that to 5/12 feet, right? From 5 inches. Here you're given 403 and 6/12 feet, 393 and 8/12. And this one I gave is 405.8. And you're given this angle here of 89 degrees, 20 minutes. Right? Use law of sine or law of cosines to find this length here. Now here you can do that area as just the 389 and 5/12 times 403 and 6/12 times the sine, excuse me, of 89 degrees, 20 minutes over 2. There it is, excuse me. That gives you that area. And then for this area, you know all 3 sides, so you just use law of Hero's formula for that. You use law of cosines to find this length, and then you got all 3 sides to use Hero's formula. That way you don't have to worry about finding that angle. Saves you a little bit of work. Number 7, you just had to find h. Anybody find h? You want to venture an answer? Somebody be brave. Because it was 389 feet and 5 inches, so I converted it all into feet. Number 7, I get h is 49.39 feet. Anybody get that? No? Does anybody have any more of these done? Or is this as far as anybody got? Kind of as far as you got? Okay, well, time to pause. How are you guys doing on the worksheet? Failing miserably? Tell you what I'm going to do. I'm going to adjust a little bit here. Give you guys some time to finish this up. I'm going to give you another worksheet to go on top of it. Just what you need. And we're going to talk about that here in just a second. Let me hand it out. So on this worksheet, you're doing things that you already know. Like number 1 there, you're going to do the inverse tangent of the slopes to find those heel angles. So this angle here is going to be the inverse tangent from the 5/12 slope. This angle here will be the inverse tangent from the, oops, I drew it backwards. This one here will be the inverse tangent from the 9/12 slope. And what you'll do then is you do this. You drop this down the middle. And once you do that, you'll know, you find the length of this slope here and the length of this slope. So once you drop this down, you can use your law of sines to find this and this, or you can just use your regular trig functions to find those as well, because you'll have 2 angles on a side. Once you know those dimensions, here and here, then add your overhangs on to get the full overhang. Okay? Then you'll have to go back and recalculate the length of that top chord with the overhang length on it. But ignore the overhangs first, because you cannot do anything with the overhangs on until you know these 2 dimensions. What's that? Regular, like sine, cosine, tangent, without having to use a lot of sines or a lot of cosines. Just your right triangle trig will work. 2 and 3 are ones like we did an example of last week, so you should be able to handle those. Number 4 is actually relatively simple. So I'll turn you loose on those. I'll give you some time. I'll check in with you in a little bit. Let me do this for number 1. Let's just take a peek at the dimensions for the end view. Okay, so this is a 5/12 and this is a 9/12. And this is 32-foot span. Yep. And 3-foot overhang and 2-foot overhang. So first thing I'm going to do is get this angle here, which is what, 26.56? 22.62, sorry. I was doing the 612, not a 512. This one ends up being what? 36.87 degrees. Okay. This one up here you can find by subtracting from 180, so I'm not going to bother with that one. We're going to cut this down the middle, though, right now. And actually, before I cut it down the middle, let me wait. I got ahead of myself. Let's find, I'm going to call this here X and this Y. So we've got, what was this angle? 120.51. So we've got 32 over the sine of 120.51 degrees equals X over the sine of 36.87. That'll give us X. Looks like we're going to get, what, 20.57? 32 times sine 36.87 divided by sine of 120.51. 22.2829. Is that right? This is sine here. Did I punch something in wrong? Well, that looks right. So this is 22.29. Now remember, that only goes from here to here. Okay? That's all that length is. So this is not the length of our top chord. It's just the length here. I'm ignoring the overhang right now. I don't have this piece on there. So now I want to find X, which just goes to here. So that was X, isn't it? Never mind. So this is 22.29. So that was X. Now I got to find Y, I should say. So it's still 32 over sine of 120.51 equals Y over sine of 22.62. So 32 times sine 22.62 divided by sine 120.51. 14.29. Correct? What's that? Doesn't work with the overhangs.
Why is that?
Because at this point it doesn't work with the overhangs. Because the overhangs aren't part of the triangle. We're only working within the triangle. So now we got to cut this here and we got to find out what portion of the span goes with each slope. The main reason it doesn't work is because this point and this point are not at the same height. So these angles do not, this would not be 22.62 here. So I'm going to label this A and B here now. Let's find A. Well, this it's a right triangle. That would be the adjacent side to the 22.62. So it's cosine of 22.62 degrees equals A over the 22.29. So I make this 1 and I cross multiply and divide. So cosine 22.62 times 22.29. 22.57 I get for A.
Todd, can you go up really quickly and show me how you got the sides? Explain that one more time.
Law of sines. I have this triangle right here. I have 32 as this side over the sine of 120.51. X over the sine of 36.87. So cross multiply and divide to get 22.29. Right there. Okay, so I got 22.57 for that one, which I can just subtract here and get 9.43 for this one. Now that I have that, here's what I have to do now to find my span. I'm going to go all the way down now to here and over. So I'm going to do one side at a time. When I do it this way, by making this a right angle, this still is then 22.52. When I do this side, though, this isn't going to come out at the same point. Notice this is actually a little bit lower here when I draw that in. So I cannot connect this point to that point because it doesn't work out. But anyway, I got 22.57 plus a 3-foot overhang. So this is 25.57 here is that span. 22.52 degrees. So I can use my trig to find that. Cosine of 22.52, or 22.62, sorry, 22.62 degrees equals 25.57 over, I'll call that J. So then I put this over 1 and I cross multiply and divide to get J. Then I'll do the same on the other side. This angle is the 36.87 here. This was, what, 9.48 or something like that? 9.43 plus the 2-foot overhang. So it's going to be 11.43 feet. So I'll use that, the cosine of 36.87 and that to find this length. So that means then once I have that, when I'm looking at my length, my roof, I'll have this length and this length. They'll just be each of them times, to get my roof, this is going to be what? A 44 foot plus a 1-foot overhang, so times 46 feet. So once that gives you the slope length, so you do that times 46 feet is the length of the roof. 44 plus 1-foot overhang on each end. Does that make sense? Not really? There's a lot of steps there. This is a tough one because you've got to draw in the triangles, find lengths. Then once you have those lengths, you got to draw new triangles and find new lengths. But the key to it is when you start out, you have to ignore the overhangs. You cannot work with the overhangs until you have split this down the middle, or not down the middle, you split this here and found what portion of the span goes with each slope. Then you can have, what's that? That was, I just cut it down and I used the right angle here. Once I knew these lengths, then I have a right triangle here where I have the angle and the hypotenuse on both of them. So that is my hint for you for the day. I will let you have the last 18 minutes to work on this worksheet and the other one. You had a question, Tyler? 23B, question 3. Okay. So this is 14 feet, this is 22 feet. This side is 12 feet, and I give this as a 40-degree angle. So we're going to cut this here. I'm going to use the, well, this would be 50, yeah. But don't necessarily need that angle. I need to get this dimension and this dimension, X and Y. So X is going to be the adjacent side, so that'd be a cosine of 40 equals X over 12. So I cross multiply and divide to get that that's 9.19 feet. For Y, it's going to be sine of 40, because that's Y is the opposite side, equals Y over 12. Which gives us 7.71 feet. Which is really all we needed, because in the area of that, we're going to do the average of the bases, 22 plus 14 divided by 2 times 7.71. That'll give you the area. I was thinking you were looking for perimeter too, which means then you'd use the 9.19 and the 22 and the 14 to find this length, and then you'd use that to find the slope. Yep, exactly. Any other questions?
Todd, you're saying that finding the area 22 plus 14 divided by 2 times.
That's just your formula for the area of a trapezoid. Average of the bases times the height. Got a base of 22, a base of 14, so you average them together, add them together, divide by 2, then multiply by the height we found is 7.71.